Okay, dear ladies and gentlemen, thank you very much having the patience to be with us in this afternoon. I will present a work done by my team. We won the contract for this hospital, which the design was started in 2014. And in 2017 start the execution, and now in 80% of the hospital it's done, and we expect next year on June to have the opening of the hospital. The hospital is located in Mioveni, in County Argeș, where it's in the town where Dacia automotive it's done, and they are a rich they are a rich municipality, and they have the capability to invest in such a hospital. The beneficiary is the city council of Mioveni. The general contractor is Medical Techniques, an association between Medical Techniques and Ital Telematic and Biomedicals, and also Garato from Italy. The general designer is my company, together with the Real Design project, which made the architecture for this hospital. Some architecture general data. There is an area when we have an hospital, an old hospital, and in the existing hospital we have building for medical analysis and laboratory, and pharmacy, building for pediatrics, building for recovery, balneophysiotherapy and emergency, building for internal medicine, building for administration and laundry, building for radiology and administrative service, and isolated buildings, which is archive, shed, garage, oxygen storehouse, more other annex. The building, which is marked with red, will remain functional after the opening of the new hospital. The new hospital building has a plot area at 13,230 square meters. The footprint area is 2,676 square meters, and gross floor area, including the basement, it's 70,000 square meters. Land to building percentage, it's 20.23%, and the floor area ratio, it's 1.29. Number of beds, 240. The height regime of building, it's underground, ground floor, and sixth floor. That means basement, ground, and sixth floor. The building is constructed with reinforced concrete columns and diaphragm, reinforced concrete floors, and terrace type of roofs. If we speak about the structure, the perimeter walls are on concrete and brick masonry. The facade is ventilated with HPL and alucobond panels, and the aluminum carpentry will be fitted with the thermal insulation windows. The new hospital main buildings functions are: on the basement we have the morgue, laundry, laboratory, kitchen. In the ground, the emergency, the investigation, laboratory, and imaging. The first floor, operating block, sterilization and intensive care, interventional cardiology. In the second floor we have operating block, neonatology and maternity. Third floor, gynecology, pediatrics. Fourth floor, internal medicine. Fifth floor, cardiology, surgery and neurology. And sixth floor, pharmacy, administrative space, technical space and warehouse. The pointer is, which one is the pointer? doesn't matter. We have a situation plan here, and we see the building 1.1 is a new hospital, that's the main building. We have the contamination building. It's important because in sistemi there is a nuclear laboratory, and the city hall asked to have this decontamination also. A sewage treatment plant, very important because we are in the hospital and we should treat the water. Water pumping station, oxygen station, and the chiller platform. The new buildings will be classified in importance category A, that means exceptional. Important class 1, it's building essential function according with P100 norms. Degree of fire resistance, it's 2 according with P118 norms, and the fire risk is low. Let's see the HVAC for the main space, the operating room. Introduction air in the operating room will be made by vertical unidirectional flow stainless steel filtering ceiling equipped with HEPA 14 type filters. Evacuation of air for operating room will be made by grills mounted on the walls, which will evacuate 25% on the flow in the upper side and of the room, and 75% in the lower side of the room. With the lower side grills placed at 10-50 cm above the floor. In the operating room, a control overpressure between 10 and 20 pascal will be maintained by a differential pressure controller, and a variable flow valve placed in the aspiration channel, so that the flow of air evacuated from the room can be reduced to ensure the desired level of overpressure. It's very important to keep this overpressure in the operating room. We will see in comparison with laboratory when we have under pressure. When it's not in use, the operating room will be kept at 50% of the nominal flow. The HVAC for intensive care rooms and sterile rooms, the treatment of air ventilated from the intensive care space will be made at treatment plant located in the technical area. That means we have an air handling unit special for this area. The air intake for the intensive care room, post and pre-operatory space and sterilization room for doctors and medical instrument will be made with Swirl type 4-direction diffuser and induction unit placed in the false ceiling. We have chilled beams systems and ventilation systems in that intensive care rooms with the HEPA filters each of them. When not in use, also we will keep this area at 50% of the nominal flow. The laboratory are located in the basement, and for that we have the National Biosafety Guide for Medical Laboratory. And after this guide, the laboratory are classified in four steps. One of that is the basic biosafety level 1, basic also biosafety level 2, security biosafety level 3, and high security biosafety level 4. The laboratory area, the ventilation systems, the fresh air provided by treatment air handling units with variable flow, with supply exhaust airflow at 5,100 cubic meter, or a simultaneity of 100%. The necessary supply of air is 5 rates per hour. Each laboratory will be fitted with a differential pressure control, system, which will maintain the pressure to the adjacent corridor of minimum 10 Pascal. The variable flow valve may be closed 100%, and so the ventilation in each laboratory can be shut off independently. The building management system is one of the most important parts of building services, because the energy performance of building, it was of the goal for this hospital, and we can achieve that through the building management system. That will be installed to ensure the automated functioning, control and survey of heating, ventilation and air conditioning system, of maintaining the pressure difference between clean rooms and with air pollution risk and adjacent zones, of the utility installation, lighting command and the survey of electrical distribution. For the clean rooms, we have special air handling units, and this air handling unit achieved the new Eco Design Directive ARP 218, and have been fitted with G4 type filters placed before the air treatment plant, with F7 type placed after the air intake fan, with the terminal distribution units in the room will be fitted with HEPA 14 or HEPA 13 filter type. The installation will run without air circulation. The introduced will be 100% exterior air. The air treatment plant is an hygienic execution. Will be fitted with intermediate fluid heat recuperator, with steam humidifier module, heating and reheating battery, cooling battery, intake and exhaust fan. Will have 2 filtration stage of intake. Very important is the system of heat recovery with the intermediate fluid, special for the clean rooms. The heating is provided by a thermal plant in the basement, which comprises three steel boilers. The capacity is 2,700 kilowatt. Fitted with dual burners with gas, fuel, modulating and the diesel 2-stage injection. The boilers work in a cascade system controlled by the building management system to maintain a constant temperature at 70 degrees on the common flow. We have after that the distributor with the pumps with variable speed, which regulate the flow in function of type of consumer. That could be air handling units, could be radiators, could be floor heating, or could be fan coils or other consumers. The cooling is provided by 3 air-cooled chillers. The capacity is 2,400 kilowatt mounted in the exterior. The chiller compressor are of screw type and run with frequency converter in a power range of 50% until 100%. To maintain a constant temperature of 5 degrees on the flow. Of course, we have BMS and the chiller working in cascade. Next to the chiller is the room of circulation path for the primary cooling agent, ethylene glycol 40%, and work between 5 and 10 degrees Celsius. There is 3 active pumps and 1 is on reserve. Domestic hot water preparation. It's made in semi-instantaneous regime by 2 plates heat exchanger and 5 accumulation tanks of 1,000 liters, each from 2 sources. One is classic heating circuit from the thermal plant, and the other is renewable solar energy, 100 kilowatt in summer period, we have 80 solar panels on the roof of the hospital. We are in the stage to sign the contract for building information modeling for this hospital, which is very useful for the maintenance. We discuss in the building in BIM from 5D, which is supposed to have the 3D design, also to supposed to having the time schedule, that means 4D. 5D include the evaluation cost BIM systems, and could be 6D, which have also the part of the maintenance, that means the details, information about each equipment, and the maintenance for 5 years should be done having this BIM, which is a tool very useful in that case. And next week I will be in Belgium to sign the contract with one of our partners, and we are on the stage to ensure the as-built design for the hospital, and also to create the database with each equipment, and in the maintenance period that we will have all the information necessary to keep the hospitals and the equipments in the good stage. And another goal for us is the building energy modeling. We will provide finally in the as-built the energy evaluation of the hospital with the energy certificate, which is mandatory now when the hospital will be opened. And through software, Hvac software, we will do also this energy modeling for the hospital. For Clima 2019, we will prepare 2 papers, one related with building energy modeling with the hospital, and another related with the building information modeling in the hospital. Of course, we spoke a lot here in 49 KGH Congress about Clima 2019. It's my pleasure to invite all of you to attend our Congress in Bucharest next year, and we are ready to promote your 50th Congress from next year, which will be held here in Belgrade. Thank you very much.